This is the introduction to section 2.5, part 1. And in part 1, we're talking about reasoning in algebra and geometry. Okay, so our objective here, we're going to connect reasoning and algebra and geometry. We're going to take algebra and geometry, we're going to put them together. All the different things we've been talking about true statements and all those types of things, and if-then statements, those are going to apply in here. Okay, so let's talk about the first thing. And the first thing we're going to look at, you'll notice, you see here, a bunch of properties. Okay, we've got properties of equality, we've got properties of congruence. Okay, so we're going to look at these and describe what these mean a little bit more in depth, and we're going to look at this first box here, the key concept, properties of equality. There are 8 of them here, the properties of equality. Okay, and in this case they give examples of what it would look like. Alright, and I'm going to go through and describe kind of each one of these quickly as we go through here. Okay, so the properties of equality, we've got add, subtract, multiply, and divide. And then we've got the reflexive, symmetric, transitive, and then the substitution property. Well, I'll start with the substitution property. It's very simple on the substitution property. We've got if A equals B, then B can replace A in any expression. You're just substituting in to an expression. Okay, that's an easy one. These 3 up here, or these 4 up here, are fairly simple. Okay, but you understand, it's not just adding or subtracting or multiplying or dividing. Okay, if you notice this, it says if A equals B, then A plus C equals B plus C. Notice what they did from this to this. They added C to each side of the equal sign. When you're using the addition property, and you'll want to write this down as we go through, this is when you're adding this is when you are going to be, you are adding a number to both sides of the equal sign. Okay? That's anytime you're using the addition property. That's what that means. You're adding a number to both sides of the equal sign. Same thing with subtraction, same thing with division, same thing with multiplication. Okay? So when I zoom in on these, I'm going to write these down. You want to make sure you have these written down on your sheet as well. This is subtracting a number from both sides of the equal sign. Again, it has to be to both sides. If it's just on one side, then it's something completely different. Okay? This is multiplication of a number to both sides of the equal sign. Okay? We're multiplying a number times both sides of the equal sign. And then the last one here is you're dividing a number from both sides of the equal sign. Okay? So these 4 properties right here, the addition property, the subtraction property, the multiplication property, and the division property. That kind of goes through and shows you you're doing it to both sides of an equal sign. Okay, so make sure you have those in there in your notes as well. The next 3 are the reflexive, symmetric, and transitive properties, and these are a little bit different. I've got some different words that we're going to put with these. Okay, so the word that we're going to tie with reflexive property is mirror. It's a mirror image of yourself. A equals A. You have the exact same thing on both sides of the equal sign. Okay? It's a mirror. The symmetric property, you'll notice it says if A equals B, then B equals A. They've switched spots. So when I think symmetric property, I think switch. Switch the order. Okay, switch the order. Symmetric property, they're switching the spots. the transitive property. Okay? Transitive property, it says if A equals B and B equals C, then A equals C. And I call this the triplets. Okay, triplets. Because in this case, you see three things and they're all equal to each other. A equals B, B equals C, then A equals C. They're all equal to each other, triplets. Okay, these are big ones. These are the important ones that you're going to look at here as we start to look at some proofs and starting to prove things. Now, transitive property, here's another example, a couple of examples with the reflexive, symmetric, and transitive properties in terms of what they look like in terms of congruence, where they've shown sides and angles in here as well. Okay. All right, now the other property that we're going to look at is the distributive property. Many of you have seen this, okay, where we take A times a quantity on the inside, and I'm looking at this right here, A times B plus C. We're going to multiply the A times both, distribute the A through. We can go backwards as well, so I could start with this and end with that. That's still the distributive property. Okay, that's another property that's important that you're going to look at. All right, so where is that leading us to? Why do we have all these properties in here, and what are we going to do with all these properties? Well, we're going to use these in proofs, and we're going to start out with some pretty simple ones. A proof is a convincing argument that uses deductive reasoning. A proof logically shows a conjecture is true. Remember, a conjecture is just a statement of fact. So we're going to actually take that statement of fact and prove that it's true. A two-column proof lists each statement on the left. The justification or the reason for each statement is on the right. Each statement must follow logically the steps from before it. The diagram to the right here, and I'll move it over, shows you exactly what a proof is going to look like. So, this is what a two-column proof is going to look like. And you're going to eventually get to where you're going to be writing these. Okay. Now, a couple important things here. The first statement is always a given statement. Always. They're always going to have a given, okay, at the beginning. All right, that's what always goes first in your statement, and the reason is given. Then we're going to have to figure out what 2, 3, and 4 are going to fill out, and we'll figure those out as we go. And then your last statement is always what they want you to prove. Okay, always what they want you to prove. That goes right here. Now, the one thing with this is that you do not write prove here, and put this down because I do not want to see anybody write prove on the bottom. Do not write prove here. Okay, the reason is not prove. We're going to have to give a different reason. All right, so that kind of gives you an idea of what a two-column proof is. Okay, now let's use the idea of a two-column proof in terms of solving these equations. You notice it says justify steps when solving an equation. So now we're not only going to solve it, but now you have to justify each step. And what I'm going to do here is we're going to we're going to put this in here like so, and then we're going to move it, and we're going to set up this equation. So we're going to set up here, as I zoom this in, we're going to make this our statements on the left, and our reasoning on the right. Reasons or justification. Okay, so let's take a look at the problem. What is the value of x? Justify each step. So as you're looking at this, you'll notice that you have a linear pair. We've seen this multitude of times. Okay, so if we were to set up the equation, we would say that 2x plus 30 plus x equals 180 degrees. Okay, and the first statement that we're always going to have is going to be a given. That's going to be our given. Okay. So, now, in order to solve the equation, what would you do first? Well, as I look at this, I'm looking at these two are like terms. So, I'm going to combine those like terms and make this 3x plus 30 equals 180. And no longer can I just solve it. You've got to tell me what reason you used. Well, I had terms that were the same on one side of the equal sign. So, this is what we call combine like terms. Okay, we're combining our like terms. It's not adding because we didn't do it to both sides of the equal sign. Okay, so now if I were to solve here, I would subtract 30, and I would get 3x to equal 150. Okay, now, my next reasoning. What did I do from this step right here to get to here? What did I do to, in this case, I subtracted 30 from each side, so my reasoning is the subtraction property. Okay? And then to solve it, I would divide by 3, and x in this case is going to equal 50. Now, again, from this step right here to this step, what did I do? Well, I divided by 3 on both sides, so this is the division property. Okay, and now I have just created my first proof just in using an equation and solving equations, being able to justify each step. Okay? All right, so what I want you to do is I want you to set this up, this last problem up, solve the equation, and then justify each step, just like I did in the problem before. Okay? Now, this keeps this pretty short in terms of examples as we're looking at these. Okay? So this concludes section 2.5 part 1, and don't forget to complete your WSQ with that.